In Mathematica, we have a number of different ways of entering expressions and entering individual commands, and this provides us with a lot of flexibility in thinking about our code and hiding some details and emphasizing others, and so on. Let's start here by clearing our definitions. Every command in the language can be written with a name that begins with a capital letter and has 0 or more arguments in square brackets at the end. This is the standard form for Mathematica expressions and commands, and we've seen many examples of it. So for example, the random word command, if we don't give it any arguments, gives us a random English language word. If we use it inside of a table command, we can get three different random words in a list. Some of the commands that we've seen, however, like plus, appear in a shorthand form. So this is how it's typically written in mathematics, but that's not the standard form of the command. Let me just evaluate this. 2 plus 2 is 4. Its standard form looks like this, plus, and then we give it the two arguments that we want to add together, and this gives us the same result. The way that 2 plus 2 is written in this first expression is what's called infix form. The command appears in the syntax in between its arguments. In a number of cases, a command has a standard shorthand infix notation. So for example, the command string join here, I'm going to use to join a little hash sign with the word hashtag. It looks like this. Hashtag, hashtag. If we want to write that with infix notation, we use a pair of angled brackets like this, and those angled brackets mean string join with these two arguments as the strings that are getting joined together. And in fact, when I hover over that shorthand, it tells me that that's an example of the string join command. I'm going to click here and evaluate this, and it gives me the exact same result when I've written it in infix notation here as it did when I wrote it in standard notation here. In fact, in Mathematica, you can write any command in infix notation if you want by putting tildes on either side of the command name. So for example, we have a command called join, which joins two lists together. If I want to write it in infix form, I can write it the first list, tilde join tilde, the second list, and that gives me the exact same result as the previous version. Same command, writing it in two different ways. The union command gives us the union of two lists. Notice that since the letter C appears in both lists, we only see one copy of it. That's why we've got A, B, C, D, E here. Written in infix form, same result. Intersection can be written in infix form and gives the same result. Now we have two additional options in addition to infix form and standard form, and these are prefix and postfix forms. So when we write an expression in Mathematica in standard form, we put one command inside of another. That's called nesting commands. So for example, if we look at this expression here, the first command to be executed is the one innermost, the innermost expression. We retrieve a random word, we then turn it into a list of individual characters, and then we reverse that list. When I evaluate this, the word that was chosen, the random word, is folktale, F-O-L-K-T-A-L-E, folktale. We take a random word, folktale, we turn it into a list of characters with the characters command, then we reverse that list so it comes out in the opposite order. In prefix notation, we can write the same commands in the same order, but we don't need all of the square brackets. So for example, this says the same thing. It says retrieve a random word, turn it into a list of characters, reverse the list. So if we're building up expressions in the usual way, the way we would in standard notation, sometimes it's useful to use prefix notation in order to eliminate some of those square brackets. It saves us the problem of having to think about matching the square brackets, and this can be quite convenient if we're writing code kind of quickly and we have a series of ideas and we're stacking them up. Here's our table that creates that creates a list of 3 random words again. If I decide that I want to put one of those words per line, I can use the table form command and wrap it around table. Typically I would write it like this: table form, square bracket, and then this table right here. It's going to give us different random words, of course, and an end bracket, closing bracket, like this. But I had to figure out where I want to put the closing bracket, and sometimes that's easier or harder depending on how much other stuff is around. Instead, if we want, we can use prefix form. Highlight this or hover over that, and we can see that it says prefix, so we know what the shorthand is. Click in this cell and evaluate it, and I get the same kind of result, although with 3 different random words. Now that's putting commands in the same order as we would see them if we were using standard form. But there's another kind of notation called postfix, which allows us to put commands in the reverse order. So for example, the way that this works is we have random word, sends its output to characters, which sends its output to reverse. This gives us the same results as in putting those commands in other orders. What's nice about this kind of notation is that sometimes you do something and then you say, oh, I actually wanted the results to be in another format or something like that. You can just use the pair of slashes to put something in postfix notation and send the output of the command on the left through the command on the right. So this is a really good way. Sometimes if you're thinking of something, you think, okay, well, I know how to do this, you do it. Okay, I know how to transform that to the next step, you do that. You know how to transform it to the next step, and so on. You just keep adding commands with postfix notation until you get what you want. Now, one of the reasons that I would introduce something like this seems kind of esoteric, maybe, is because when you're reading the Mathematica documentation, the programmers who wrote that constantly make use of these various kinds of things. So sometimes you'll see an expression in the Mathematica documentation that does what you want it to do, but it's not immediately obvious to you how it works. Another option when this happens is to use what's called hold form. So for example, in this expression right here is the kind of thing you might see in the Mathematica documentation. It might not be immediately obvious to you what it does. Obviously we have a list of pairs, a list of pairs where each pair is a list in its own right. We have the command rule, and we have something going on here. If we hover over this, it tells us that that's apply. If I hit Shift Enter on this, it takes this list of pairs and turns it into a list of these rules, and those rules are very useful in creating associations. If I want to take a list of rules and convert it back into a list of pairs, I can use this expression, but once again it's not immediately clear how this replace all command works or what it's doing. So we have a couple of options when this happens, and one of these options is hold form. What hold form does is it says, don't actually evaluate this expression, just show it to me in standard notation. So if I go hold form on 2 plus 2 like this, it just shows me that that's 2 plus 2. If I try it on a rule, on this expression up here, rule applied to this list, it tells me that what's happening here is I'm using first the command apply, then the command rule, and then I'm applying it to this list here, and then this one in curly braces is an argument to the apply command. This expression here, the hold form of the previous expression, it's not immediately obvious how those two expressions are related, or in fact that they are the exact same expression. So if you're trying to unpack how things work while reading the documentation, knowing how to use hold form can be quite useful because it can show you the exact same expression in a different form that might make it more obvious what's doing. Now this doesn't always work. If we try to use hold form on our replace all command here, it just gives us the same expression that was on the inside. But if that held form still is unfamiliar to you, one of the tricks you can do is you can then wrap that whole expression in what's called full form. Let's try that here. And now when we do this, we see the entire thing spelled out in quite a lot of detail. We have a hold form, replace all, a list with a bunch of rules, and a rule that contains a rule in the list, and so on. Again, a fairly complicated expression. If we're going to try to read this code, we have to go back to the documentation and figure out what each of those things is doing. But by spelling everything out explicitly like that, it allows us to tell, it gives us clues that we can use to better understand what the code is doing.